Okay, good. All right. So I prepared several problems. Some are from homework. Some of you will see that later. All right. So this is let's begin with the first problem. You know, this is a problem on numbers. How do we deal with this kind of problems? All right. So what is the largest positive integer? That is a fact of every 4-digit even palindrome. Okay. So what does that mean? By definition, okay, for palindromy is a number, right, in the form like A, B, B, A, right? And it's even means A is going to be even number, okay? A is going to be an even number, okay? So we want to make sure the number you're looking for is a fact of all such 4-digit numbers. So how can we solve this type of problems? Well, we should know how to express 4-digit numbers using the digits. Okay, we know that 23 is going to be 2 times 10 plus 3, right? Okay, so this is how do we do that? So A, B, B, A can be written as A times 1,000, B times 100, B times 10, and A. Okay. Right? Okay. So as you can see that A times 1,000 plus A is going to be A times 1,001. Okay. B is going to be B times 100 plus 10 is 110. Okay. Now each of them, okay, especially 1,001, okay, is divisible by 11. Okay, we're trying to find a common fact. Okay, divisible by 11. Then after you divide by 11, you get a quotient. It's 91. 11 times 91. And this one, 110 is 11 times 10. So at least there's a common fact. Okay, there's a common fact. It's 11. Okay, now be careful. A is an even number, right? So A is an even number, so I can even express A as a 2p, okay, 2 times an integer. So then that's a 2 times p. So then I have a 2 here. 10 is also 2 times 5, right? So there's another factor 2. You can take it out. That's a p times 91 plus b times 5. Okay. So all such integers can be written as this form. Okay, they all contains a factor of 22. So now it's clear that the answer is 22. 22 is the greatest common divisor. It's called the GCD, the greatest common divisor of all such integers. Okay, and this number, depends, right? And you can check that I don't find any common factors on those two. So there's no, so I cannot, So now it's clear that the greatest common divisor is going to be 22. Okay. I think 22 is the answer. Okay. And you can check that when P and the B changes, okay, when P and G changes, I don't have I don't get another common factor, okay, out of that. Because look at that, P, how many choices for P? P is going to be, I think P cannot be 0, so 1, 2, all the way to 4, right? P cannot be 5, because A and B are integers, okay? A and B are digits. So B can be, B is in the middle, right? B can be 0, 1, 2, all the way to 9. So for those choices, how many integers you're going to get? Well, 4 times 10, 40 integers. And I don't think you can get a common, non-trivial common factor out of that. So 22 should be the only factor right now, largest fact, okay? The only fact shared by all those integers, okay? So that's how do we solve the problem. All right, our next problem. So from this example, we know how to express integer using its digits, okay? Right, so now our next problem is what is the smallest positive integer n for which 0.5 to the power n, when it's simplified, where it has a 0 immediately to the right of the decimal point. So what does that mean? That means we are trying to find the n, the smallest n, okay, such that this can be in the decimal form will be 0, 0, and some numbers here, okay, some digits here. So of course, when n is too small, this is right, this is just 0.5, so does not meet the requirement. Okay, does not satisfy the requirement. So we have some already here the answers. Okay, so 0.2, and just try several ones, right? Okay, I prefer to express as 1 over 2. Okay, 1 over 2 squared is 1 over 4, and clearly 1 over 4 is 0.25, and that's not, it does not satisfy the requirement. Okay, 1 over 2 cubed, 1 over 8, 0.125, still not. Okay, 1 over 2 to the 4th power, then you will get 0.0. Okay, 1 over 16, 1 over 16, 16 is larger than 10, so that's why you will get 0 here. Okay, 1 over 16, 0.025. Okay, so that will be the answer. So n should be equal to 4. Okay, n should be equal to 4. Right, clear. Anyway, when you increase the value of n, and you decrease the value of 0.5 to the power n. So eventually you get lots of zeros there. So the first n you can get, right? First number you can get for the power, so that there'll be 0 to the right of the decimal point is n equals 4. Okay, so this is not a difficult problem. Just try several ones, and you get the answer. All right, so the next one, the problem is a little bit complicated. Okay, let's finish reading it. Okay, let's read it first. So what is the sum of all digits of the product? Okay, 9999 and times 44, where the first fact is 100 digits number. Wow, that's 100 with repeating digit of 9. And the second fact is 100 digit number with a repeating digit 4. So what is the sum of all the digits? Yeah. Well, okay. I copied it twice, right? No, that's the second question. So what is the sum of the digits of the product when I replace 4 by k, where k is the first is where the first fact is an n digit number was repeating digits. I just generalize it, and the second fact is the n digit was repeating digit of k. Okay, so that's a little bit more general, right? And if when k equals 4, n equals 100, that's the problem, the first question. So let's see, what is n here? This is n, right? And that's a k, right? Okay. So if k equals 4, n equals 100, then that's the same question as above. Okay. So if you're able to solve the first problem, more likely you're going to solve the second problem. Okay. Okay. Let's try, right? How do you do multiplication? You can say there are a couple ways to do, right? Someone will try, okay, 9 times 1, how many digits, right? So you have a 100 digits, so 10000, right? Okay, look, you can try this.
A power of 10, so you could just do 4, 4, 4, 4, 4, and then there's zeros at the end, minus 4, 4, 4, 4, 4.
Yeah, well, okay, so you can give me yo-yo, right? So what is the result? Your question is, right? All right, so we were, 999, right? It's going to be, right? You can express in this form, and times 4, 4, 4, 4, right? Okay. So okay, so when you multiply this out, then there'll be 4 and 4, 4, 4, 0, 0, 0, right? How many zeros here? And you have 100 zeros. Here's 100, right? Okay, and then minus 4, 4, 4, 4. It's also have a 104 here. Yeah. Then I think you can even write down the number. Okay, you borrow from yeah. So what you do is when you do the subtraction.
The last digit you get 6, and then you have 99 fives, and then
no, that's great. You're right. So you have a 4 here, then you already borrowed, it's lost 1, right? So you have a 99 here, make sure that. Then you have a 5, 5, 5, 5. You have a 99 5 here, and that last one is 6, because 10 minus 4 is 6. Then the rest of them just the 99 and the 5, 5, right? Yeah, because the 9 minus 4 is 5, 9 minus 4 is 5, 9 minus 4, 5. So you get the answer. Once you get this, right, then you can add them together, right? The sum of the digits, okay? Then you can get, right, 4 times 99 plus 3, 5 times 99 plus 6, right? Right, and then just add them together. And you can also, you can also do simple multiplication. 4 plus 5 is 9, so 9 times 99 plus, right? Let's see, 4. Okay, so it's 9 times 99. Then I also have 3 plus 6 is also 9, right? Then you take a 9 out, and 99 plus 1 is 100. So that's why, how do we, you can quickly get, okay. Okay, the 900, right? All right, so now you can also generalize this to, we right now, what is right? If we can generalize this k here, and I think it's similar. I don't have very much space to left, so you can express your answers here. You can solve the second part by similar argument. Okay. Yeah, just replace 4 by k, then you get, but then n digits, then 99 replaced by n minus 1, something. And finally, you will get the answer. Okay, so I can change, k to be 3, let k to be 3, let k to be 2, And the idea is exactly the same. So I don't need to repeat the same, okay? Same idea here. So if you know how to solve this problem, you can solve the second problem, okay? All right, so now let's take a look at the next problem. The next problem, okay, the next problem, it's similar to the above problem. Look, okay, think about it. I have to go back. If someone gets the wrong direction, then what happens is that 9, right, times 4, 4, 4, right? This can be 9 times 1, 1, 1, right? 100 ones. And times 4 and times 1, 1, 1, okay? Right? So you will get 4 times 9 is 36, and then you have a square here. That is 100 right here. You see, 36, right? Then you have trouble to do the multiplication here, you know, and you have 100 ones here, then square, right? And that's easy to find out, but then you have to multiply by 36. So that would be the wrong direction in order to solve this problem, okay? But this one square is going to be 1, 1, 1, right? Times 1, 1. So when you multiply this out, you will have a, you know, right? And then the second one times 1, 1, right? So you will see that, yeah, it's pretty complicated when you add them together, okay? Finally, the shift here. It's a pretty strange number actually. Okay, when you round it down, you know, if we just 11 square would be 121. Okay, 111 times 111. Okay, then it's not, yeah. So you see that, right? So you get a 1, then you get 2, you know, you get, yeah, I'm not going to finish this. So it's not easy to solve the problem if you go in that direction. Okay, so now let's take a look at the next problem, right? So here, this is a problem related to the above, right? So what is the sum of the all digits product? So if you do the way, you know, just like do the multiply this out directly, then you cannot solve. Right now, since I just showed to you, okay, this 36 is 4 times 9. Okay, so that'd be 4 times 9, just go backward. Okay, then you get 9 times 4 and 4, and here you have a 100 and you have a 100. Then you get the sum of all the digits. So sometimes, yeah, you have to change the way to multiply them out. So this is associated with the previous problem. Okay, I said that, you know, if we are given this and eventually end up with this, then maybe it's very difficult to find out the sum or the product. Okay, you know, the product here, you know, right? This is answer the product. So if you express it in this form, the original form, right? Then you can quickly find the product. Okay. All right, so let's move on to the next problem. What is a common fraction? It's equivalent to this. Okay, in mathematics, it is written in the form 0.54. Okay, put the bar on the top. It's called the repeating.
Well, 54 over 99, which also equals 6 over 11.
Okay, yeah. So some of you know that if it's if I have 2 digits repeating, then this is going to be 54 over 99. Okay. Then after you simplify, you know, this is 6 times 9 and 11 times 9, then it is 6 over 11. Okay. Now this problem, but why this is true? You know, why divide by 99?
Move the 4 up, so by 100, and then you have to minus that regular one. You get 100 minus 1, which gets you 99.
Okay. So actually what is that is going to be 54. You see this number, okay, can be written in the form 0.54 plus 0.0054 plus 0.000054 and keep it going, okay, right? Then each of them here 54 over 100, that's a 100, right? And that will be 54 over 100 squared. Okay, that'll be 54 over 100 cubed, okay? So as you keep it going, then in order to add the infinite many terms, what you can do here is you take 54 over 100 out, each them, then you get the 1 here, and the 1 over 100. Here's a 100 square, and then probably 100 cube, and so on. Okay. So the question is how to add those numbers together. Okay. In mathematics, there's a formula here. Okay, I'm going to talk about. Okay. So actually, the formula says that if you have 1 plus r squared, r cubed, you have add all the infinite many terms together, that's going to be 1 over 1 minus r if the absolute value r is less than 1. Okay, this is called a geometric series, and we know how to add them together if r is small. Okay, so right now r is 1 over 100, so that's why, and it's going to be just 1 over 100. Okay, then you simplify it, and that is going to be 99 over 100, and then the 100 canceled out. Then that's the reason you always get 54 over 99. Okay, I just trying to explain to you why, when you convert the number in a decimal form with repeating digits to a fraction, why divide by 99? And this is where how do you 99 shows up here. Okay. All right, so, and this involves a geometric series, okay? How to add infinite many terms together, and then the sum will be considered as a limit of the sum of these finite many terms, okay? All right, so take a look at the next problem. I want to try first, okay? And this is a question here. Yeah, I hope you can see it. Yeah. So it says that Joshua chose a 2-digit positive integer, and he added 10 to the number, and then multiplied the sum by 11. The result is less than 1,000. What is the largest possible value of Joshua's the result? Okay. So you want to figure out not the original number, the result. Okay. So right. But if you can figure out the original number, then you see the result. Okay. Right, do you understand the question? So Joshua has a 2-digit number. Okay, he chose a 2-digit number, and then he added 10 to the number and multiplied by 11. And this is a smaller than 1,000. So this kind of result, how big you can make it, which is smaller than 1,000 but close to 1,000. Okay. Well, you have to solve the inequality, right? X plus 10 times 1 times 11 is supposed to be less than 1,000, right? Okay.
Then we can act it as if it's an equation.
Yeah. This is the inequality. Yeah. Just solve this inequality. X is the integer. Okay, that's the original number he has. You write down this this inequality based on the given information. Then you try to solve for this inequality. So first of all, you divide by both sides by 11. Okay, this is about 90.9. Okay, something like that. Okay, then then the largest, you don't even find x. Okay, then the largest possible value you can get is 90 for x plus 10. X plus 10 should be about, okay, is less than 90.9 something, right? So but the largest integer you can get for x plus 10 is 90. So in other words, x is going to be 80, okay? But you really don't need to know the exact value for x. But all I needed to is this is times 11. I know it's x plus 10, the largest value is going to be 90. So 90 times 11, so 990. So 990 is the largest possible value of the Joshua's result. The result means after he does, add 10 to the number and then multiply by 11. Okay, so that is the answer. So this problem, you just need to translate the statement into the inequality and solve this inequality, and choose the largest possible value for the x. Then you can answer the question. Okay. Okay. So now the next problem. Okay. The first sequence shown here is arithmetic. The second sequence is geometric. Okay. After 12, what is the next term the sequence have in common? Okay, 12 they both have, right? 12, 12, both contains 12. That's already know that, we don't need one. So we're trying to figure out the next number. Okay. Okay. The next number shows up in the both sequences. Okay. This, yeah, you can list few more terms, and you probably can quickly get it. Now, if I ask you to find all of them, then it'd be challenging. Okay, find all the numbers in both sequences. Okay, then that would be difficult. Okay, so yeah, let's write down the first one. First one, okay, increase by 9 each time, so it's going to be 30, 39, 48, 57. Keep it going, right? The second one is going to be multiplied by 2 each time, 3, 6, 12, 24, and 48. So then 96. Then you will see that those two numbers, okay, 48 are the next number in the both sequence. Okay. Now, if you're trying to find all of them, then you have to express the first one in the form in the sequence, right? So if you want to find all of them, now some students will do that. See, if I give you a problem like that, right, and you solve it, now probably that's not the end of the story. Now, a good student will ask, what is the third one in common in both sequences? How can I determine all of them? Now, if you keep thinking like that, you potentially can become mathematician, okay? Or scientist. You can do the research when you read an article, somebody already did an experiment. Okay, you have to think about that. Why not in general? Can I figure it out, right? So this is and you are capable to do that. And maybe the next one, and if you write down more and then maybe you can show that, hey, there's no other numbers in the both sequences, then you prove that, right? So I wish you have this kind of ability, okay? No matter whether you're going to do, you're going to do math or biology or chemistry in the future, okay? So yeah, think about that. I'm not going to show you this more, but can you find the third one, okay? In further number in both sequences, or if you cannot find it, you can prove that there's no such, okay? Okay, so let's move on. I don't have a space here, and it takes the whole day even discuss this problem. Okay, the next problem is, okay, if the least common multiple of A and B is 20. Now, what is least common multiple? Okay, and what is least common multiple of 15A and 15B? Least common multiple is a multiple. First of all, it's multiple for both. Okay, right? And so list the common multiple. So A and B, right? Yeah, based on that information, okay, we will see that 20 is going to be A times N, right? Right? It's 20 is multiple A. 20 is also, it's a B times M. Okay, and it's not necessarily N, okay, it's the same number. So 20 at least, is multiple A and B, right? The least there's the smallest common multiple is the smallest value. So now 15A, 15B, I multiply 15. Okay, so 15 times 20 is going to be 300. So that's a 15A times M. 300 is a 15B times M. Times M, right? So 15A and 15B, okay, 300 are both of them multiples of both numbers. But then I think it's clear that list the common multiple of 15A and the 15B is going to be 300, okay? And you cannot get a smaller than that, okay? Now you can give an example. A could be 4 and the B could be 5, for example, right? At least the common multiple would be 4 times 5 is 20. Okay, you can look at the example. Okay, A is going to be A is a 4, B is 5. So least common multiple 4 and 5 is going to be 20. Okay. Then you multiply each by 15. Then 4 times 15, B times 4, 5 times 15. And then the least common multiple for 15A, 15B is going to be 300. And you can use the example, double check it. All right. All right, so now we have another problem. Here, I wanted to work on that. Okay, and the odd integer between 600 and 800 is divisible by 9 and 11. What is the sum of its digit? So the question,
Find the LCM of 9 and 11, and then see if that LCM has a multiple that's between.
Yeah. So first of all, when you read this question, sounds like there's only one odd integer satisfying this condition. Okay, otherwise, if they have two different odd integers, then you maybe get two different sums of their digits. Maybe you can still get the same digit. So it's possible, but But if you just want to find an answer, if it's a multiple choice problem, right, then you just find one particular example. It's enough. But I'm going to show you there's only one such number there satisfying these conditions. Okay. So please work out this problem. So anyone has an answer? All right, let's see, who is that? Now this is a little bit difficult than the previous problem.
I think I sent it to you.
You got it? All right, first of all, this is another, right? I think we can do a quick way. It's a 9 and 11 that do not have a common factor. So we are looking for a number divided by 9 and 11, then if and only if it is divisible by 99. Okay, if and only if.
So 9 times 11 equals 99, and you have to multiply.
Yeah, 9 times 11 is 99. Okay, because there's no common factor there. So you just product. Okay, so how many numbers there? You see, so we are looking for the integers between 600, 800, and which is multiple of 99. So 99p greater than 600, less than 800. Okay, and also this should be odd number. So that means p must be odd, cannot be even. Okay, because with p is even, you get the even number, right? 99 times even number is 99, and is an even number. So p must be odd number. When you solve this in Cordy, and you immediately get the answer, because 800 divided by 99, and here's 600 divided by 99. So we simplify, it's going to be 8.08, and this is going to be 6.06. Okay, 6.06. So let me erase. Yeah, probably cannot see it. Okay, so this is about 6.06. So p is between those two numbers. Since p must be odd, must be integer, then the only possible solution for p is 7. Okay, so the answer is, the number is 99 times 7, which is 693. So we find this number, and then you can add all the digits together. Okay, so 6 plus 9 plus 3 is going to be 18. Okay. So that is a unique number between 600 and 800, which satisfies the given condition. Okay. So the idea is, you express a number as multiple of 99. Okay. Then now if I change 9 and 11 to 9 and 12, then a number divided by 9 and 12 is not divided by 9 times 12, okay, because 9 and 12 has a common factor of 3. So you have to be very careful about that. Okay? Since here 9 and 11 do not have a common factor. So that's why a number divided by 9 and 11 if only if it's divided by 99. Right? then you can express such number in the form 99 times p. All right, so let's move on to the next problem. A second and fourth digits of a 5-digit integer n are interchanged to form integer k. Okay. And when the remainder, so the question is, what is the remainder? Okay, what is the remainder when this number is divided by 11? So not when. Okay. What is the remainder?
What is like interchangeable?
Yeah, what is the remainder when it's divisible by 11? Divided by 11. Okay, so you have a 4-digit number. So it's a 5-digit number, okay? The second one, the fourth digit of a 5-digit number interchange, okay? So you can take a look at example, okay? Then you can answer the question, you know, and the number, original number k, n equals, let's say 1, 2, 3, 4, 5, then k, the second one, and the fourth one, you interchange, right? Then you take the difference. So n minus k could be negative, so I put absolute value here. 1, 2, 3, 4, 5, minus 1, 4, 3, 2, 5. And just use the calculator directly, and then you get 1980. Wow, 1980. And of course, it has many factors there, right? And this is divided by 11, so let's divide by 11. When I divide by 11, I get an integer. So that means that in this particular case, the remainder is 0. Now, if you know the answer is definite, okay, then you probably just use the example already answers the question. So you say it's divisible by 11, that's why the remainder is 0. Right? Now there's a small possibility then the answer cannot be determined because different choice of n, and you end up with different remaining. Okay, that's a possibility, okay? So it's possible that even people ask you this question, what is the remainder when this, sounds like there's only one unique answer here, but then could be say it's not determined. So you can try another example, and it's always get remainder, get 0, then you can, in mathematics, you can only say, hey, I conjecture, the remainder is always 0. But as a biologist, if you do the 2, 3 experiments, you always get the same result. Then they publish a paper, say this is true, it sounds like a true fact, okay? But then the textbooks in biology would be revised every 10 years probably, because later on people find out, oops, it's not the case. After I did after then the conjugate experiment, I find something different. Okay. In mathematics, you cannot publish your papers after you test it. After you check that into special examples. All right, so the remainder is going to be 0, and now we're going to prove that in general, okay? How do you do that? It's a 5-digit number. I'm going to let 5-digit number A, B, C, D, E, okay? This is a 5-digit number. The 5-digit number can be written in the form, right? 10,000 times A, and the 1,000 times B, 100 times C, 10 times D, and E, okay? So now, what is K? I interchange the number A and D and D and B, right? So this part is the same. And that's a D. 100C and the 10 and the B, N plus C. Now then when you look at the difference, I think A is gone. And C is also gone, E is gone. So what you get here is you only have this two, right? So 1,000 minus 10 is going to be 990. Then 1,000 minus D, so it's, yeah, okay, that's what you get, okay? Then you take the common factor out. So what you conclude that the difference of this actually get more than that, you know. So this is always divisible by 990. Wow. It's divisible by 190. Of course, it's divisible by 11 because 990 is divisible by 11, right? So 990 is going to be 99 times 10 is 9 times 11 times 10, right? The prime factorization gives you, gives you 2 times 3 squared times 5 times 11. So anyway, so 990 is always divisible by 11, divisible by 5, divisible by 9, divisible by 2. Okay. Of course, this difference when you divide by 11, you will get an integer. Okay, you don't get the remainder. The remainder is 0. Okay, so it's always the remainder is 0. Okay, so the remainder
is always 0?
Yes, when you divide by 11. Okay, so if you can get to this point, show all the details, then that's the statement true in general. Okay, and doesn't matter which specific examples you're going to, what specific number you're going to choose. It's always a multiple of 990. It is always divisible by 11. Okay. Now, if you only try a couple different numbers for n, and then you look at the difference and you find out it's divisible by 11, yes, for the problem on the exam, maybe you just put the answer there. Okay, the remainder is 0, because if you assume that the answer is definite, only one answer there. Okay, but that's not the fact. True. That's not, this just in mathematics there's conjecture. Okay, so you have to prove that in general. Okay, prove that in the general case, for the general case. Then this is a perfect answer. Okay, so 11. Number 11. Let's take a look at number 11. I want you to work out by yourself. Okay, so you got a pretty good idea. How do we solve this kind of problem? Okay, Rebecca's answer is correct. Anyone else?
I just got 8 times 100 plus C minus C times 100 plus A.
Okay, you have to find the largest factor, right? Now, when you get the answer, you have to show to me why this is a correct, okay? Why this is the largest one?
Wait, could the largest factor be a variable too?
No, it's a definite. It is it's a number. All right. Nobody else give me the answers. Yep. So ABC minus CBA. So ABC can be written as 100A plus 10B plus C, right? And minus 100C plus 10B plus A. So 10B is gone. You have a 100A minus A, and 99A. And then C minus 100C is a negative 99C. So clearly, this can be written as A minus C. Now, A minus C can be any number. Can be A minus C could be 0, could be 1, right? What is the possible value of A minus C? Right? It depends, right? So A cannot be 0, C cannot be 0. Otherwise, those are not three-digit number, right? So the smallest possible value you will get is A minus 9, okay? So this is going to be 9 minus 1. So it's between 8 and negative 8 and positive 8. Okay? So A minus C can be any of these digits from negative 8 to positive 8. Okay? Okay. Could be 0. So, clearly is the largest fact. Okay, the largest fact is 99. Okay, right. So answer is 99. Okay. There are some factors. Find the largest fact. Yeah, the common fact. I mean, yeah, the common fact we call the largest common fact of all those. So L common divisor, yeah. Largest common divisor, 39. Okay. Okay. All right, so now take a look at the next problem. What is the greatest positive four-digit integer? That is a product of two consecutive integers. So consecutive integers, so k times k plus 1, right? Okay, k plus 1. And this must be 4 digits in the integer. So it's less than or equal to 9,999. And greater than or equal to 1,000, right? 1,000 is the smallest 4-digit number. 9,999 is the largest 4-digit number. But we only consider those integers which comes from the product of consecutive numbers. Now let's figure out the possible value for k. So just look at this. Well, we're looking for greatest possible for the. So you only need to consider that's in quote. Okay. So this is a. So what is the what is the possible value for k? No, I don't want to solve a quadratic question. Okay. What I'm trying to do is I look at this is a k times k, right? It's k squared. So I'm looking for perfect square, which is less than or equal to 9,999. Okay.
Wait, 9,900?
Yeah. Can try now, right? So if you don't use that, then you will see, right? You get 100 times, right? 100 times 101 is going to be greater than, clearly is greater than 10,000, right? Yeah, 10,000, it's already larger than 999. So then the next number you can try is 99 times 100, right? Which is going to be 9,900. Okay, and that should be the answer. Yeah, then if this is still greater than 9,999, then you try 8098 and 99. Okay. Similarly, you can find the least positive 4-digit number that is a product of two consecutive integers. So how do you do that? Well, then you go to the other side. Okay, other side, you only need to focus on this side. And by guessing, try. I think I know 30 squared is 900. So I probably use that k to be 30. I want to make it larger than, right? So 30 times 31. Well, it's going to be 930. Okay. Then 31 times 32, 992. So still, it's less than 1,000. Then 32 times 33. Okay, then it's going to be 1056. It's greater than 1,000. So clearly, in this case, this should be the number. Okay, k equals 32. Okay, so the answer is the answer is 1056, which is a least positive 4-digit number. It is a product of two consecutive integers. Okay. All right, so that's all for today's class, and we probably have to continue on one more lesson on the numbers. And maybe if I postpone that, then I'll pick up the geometry next time. Okay. So I haven't decided yet.